Hello guys, welcome to my channel. Today we are going to discuss about maximum and minimum of some functions. Okay, this is the channel in which we are talking about the mathematical physics which is very concentrated on IIT JAM curriculum. This is Adam Leonardo Cap, and in which today we are going to talk about the maxima and minima of some function, which is again based on the concept of partial derivatives. So if you are new to this channel, please subscribe and share to your friends, and let's get started now. Okay guys, so let us first try to understand that what is this maxima and minima of a function. तो अगर guys आप लोग नए हैं तो मेरे चैनल को जरूर सब्सक्राइब करें और पहले हम ये समझने की कोशिश करते हैं कि maxima और minima क्या है. So I think you first have encountered such terminology when you were class in 11th and maybe 12th. So you understood from their previous study, like suppose there is a function which depends on only one derivative, let us say x over here, and in order to find the maxima or minima, first of all what you did is that you first try to find out the total derivative of that function. Since it is dependent on only one function, then you just equate to 0, and for that you gonna solve for x and you will get some particular value, and then you will what you got that you can again try to find out the second derivative of that function, and then you evaluate at those points. Let us say this is at about x of star. So x star is some kind of constant. Well, I'm going to take one example. For an example, let us say d2f over dx square, I need to calculate of some function that is given to us like f is equal to x square. This function is kind of parabola. So I want to understand, let us say that, okay, what could be this function at some particular, let's say 1 and 2. So what you can do is that you can just simply find out df over dx, and it will give you 2x is equal to 0. Now here you can see the problem. The problem is that x is just only 0. You cannot have any arbitrary number of value. But we can easily see that this function at x is equal to 0 will have some minima. But the problem is that how we can explain it. You can explain how you can just calculate d2f over dx square and it will become 2. And since 2 is greater than 0, therefore we can say that if the second derivative of that function is positive, then we can say that this function is basically negative at that point. Now since x can only take only one value 0, so it has only exists some minima and there is no maxima of that function. अंडरस्टूड. सो ये कहने का मतलब ये होता है कि देखो मैक्सिमा और मिनिमा का पहचान क्या होता है कि जैसे तुमने एक फंक्शन को देखा और उसमें क्या होता है, हमेशा मिनिमा एग्जिस्ट करेगा यहाँ पे. अब जब मैं इस मिनिमा की बात कर रहा हूं तो तुमने ये देखा होगा, ये जो पॉइंट हमने देखा वो क्या होगा, जितने भी आप नेबरहुड में चले जाओ उस नेबरहुड में जो भी फंक्शन की वैल्यू है वो क्या होगी, यहाँ से ज्यादा होगी. सपोज ये मेरा क्या है, ये 0 है, तो यहाँ पे 0.1 है, तो 0.1 का आप अगर स्क्वायर निकालोगे तो क्या मिलेगा आपको, 0.01 मिलेगा ना आपको जी. Then it is again greater than 0, isn't it? So अगर आपने कोई एक पर्टिकुलर फंक्शन लिया, let us say x फंक्शन लिया, और आप उसको देख रहे हो in the neighborhood, let us say at some kind of locality where h is giving you some neighborhood points, then अगर ये neighborhood अगर आप इसको माइनस करोगे, let us say f of x plus h माइनस f of x, ठीक है, तो मुझे पता है कि यहाँ पे इस फंक्शन की वैल्यू ग्रेटर है, यहाँ पे इसकी वैल्यू मिनिमम है. तो अगर मैं इसका नेगेटिव में करूंगा, इन दोनों को अगर मैं नेगेटिव करूंगा तो यहां मुझे रिजल्ट क्या आएगा, ऑलवेज पॉजिटिव आएगा. यस, तो कहने का मतलब ये है कि अगर ये इस टाइप का चीज दिखा रहा है तो इसका मतलब क्या होगा, जो फंक्शन होगी वो हमारी क्या हो जाएगी, ऑलवेज मिनिमा होगी. On the other hand, we can take another example. Another such example would be, what could be the another example? Let us say I have this kind of scenario when you have some kind of function. Let us say your function is type से defined है. Let us say you have only x variable and there is a function over here. Now you may say that okay fine, how we can just tell you that okay, f of x is equal to I'm gonna consider, let us say x square minus of what should I take? Not x square minus 2. Let us say x square minus of x cube. Okay. So consider we have this kind of function. So if I'm going to calculate df over dx, then it will become 2x minus 3 of x square. And if I'm going to take equal to 0, then I can easily learn that there is a one thing called x is equal to 0 and another one is just 2 minus 3x is equal to 0. And therefore we are going to get here x square. No? Yeah. So one of the functions just take x positive and therefore you will get 2 over 3. Okay. So now if you want to try to find out the second derivative of this function, then what will I get? I will get 2 minus 6 of x, because take one of the derivative over here, and then you're gonna say that, okay, I'm gonna let it, and I'm gonna put over here 2 by 3, 3 2s are, and 2 minus 4, which is minus of 2. Now this minus of 2 is negative. Now, since d2f over dx square is negative, and what we can learn from here, we can learn that this d2f over dx square at this particular x is equal to 2 by 3 is going to show you the maxima of this number. Okay, so this function is maximum at this thing. So that is the meaning of this thing. Suppose that you have a point, you have a function over here, and at some point, let us say x is equal to a, you will get some some value of this function at x is equal to a. And consider that if you evaluate at some kind of neighborhood, like here f, a and h, so you can see that there is only one maximum over here. So if you take just here, so this point or this point is always be lower than this point, isn't it? So when some function has only one particular maximum value around the neighborhood point, then we can say it is a maximum. Then what could be the condition? The condition, if I'm taking that, let us say x plus h in the neighborhood, and if I'm just considering like f of x around, let us say x is equal to a, you can say that. And if coming out to be, because in the neighborhood, this is called the neighborhood, and when we are talking about x is equal to a, let us say at is equal to a, f has maxima, and in the neighborhood, so we know that at x is equal to that point, it will become maximum. Therefore this function is maximum, therefore it will be 0. So when this happens, then we can say that this function is maxima. So you now understand that how we can determine the maxima and minima, and this this concept goes from the concavity and convexity. ओके, सो इसे मैं कह सकता हूं कॉन्केविटी डाउनवर्ड, और इसे हम कह सकते हैं कॉन्केविटी अपवर्ड, ठीक है ना। तो मैं अभी लिख देता हूं कॉन्केविटी डाउनवर्ड का मतलब क्या होता है। दिस इज अगेन द कॉन्सेप्ट दैट यू हैव ऑलरेडी लर्न इन योर class 11th and class 12. So concavity downwards. Okay. So concavity upward का मतलब क्या होता है, ये ऐसा रहेगा और ये ऐसा रहेगा. When this happens, this is giving you the maxima of any function, and this is giving you the minima of this function. So now we understand perfectly what happens to the function if function is just depend on only one particular value but not the other particular values, like if it is just only dependent on, let's say, x. On the other hand, now since we are in a partial derivative and our function can take more than one variables like y, z, and so on and so forth, then how are we going to determine the complexity? How are we going to determine the maxima and minima, or maybe some extremum condition of those functions which could have now have become very complex? And this analysis is, I am going to tell you now, I'm stressing over it, that this concept is very important. It's crucial to understand this concept. Okay, so let us try to understand that how we can handle this kind of concept. Okay, so first of all, the thing is that whatever we have learned so far up to this point of function of one variable, it simply translates to the same thing will happen if you have more than one variable. Like, let us say we have that only one point, and let us say x is equal to a and y is equal to b. At this point, the function can be maximum or minimum. Okay, we need to check it. So first of all, what I'm going to is say that, let us say we have two different neighborhoods. Let's say that in x direction, you can just take, let us x is equal to a. So x is equal x plus h. Over here you can make a circle of like this, of radius a, then of radius, sorry, h. Then you can say that, okay, this is kind of giving you the neighborhood of x, and then y can be given you the neighborhood of y. Okay, so that is the idea. So you can say that, okay, I am going to, so what I'm going to try, that, let us say x plus h, okay, and y plus k, and if I'm just subtracting with some general function f x comma y. Now on the other hand, I have to be specific, I have to be specific that which function you are talking about. Then what we need to do, I need to specify this x. Okay, so this x and y are the critical points. Then I have to say that, okay, fine, what I'm trying to understand is that so for a particular point, so this x will become, let us say, a comma b. So I can simply write here that a plus h and b comma k Okay, now b comma k, now b plus k, and then I'm gonna subtract it with some particular value of that function, and if it come out to be positive, then it's minima. If it come out to be negative, then it's maxima. Okay, so this is called minima and this is called maxima. Okay, so I hope this function, this is clear to you. Okay, so now the problem is that how we going to determine this, because this is the condition we perfectly aware of, but how we can determine it. So in order to determine it, I am just not giving you some complete idea that how I'm not going to derive you in front of you, but I'm giving you the complete outcome, that whenever we try to do such thing, we just first try to evaluate the Taylor series expansion. The concept is just Taylor series expansion. Okay, so I have already made a video on Taylor series expansion. You can check it out, that how we can elaborate the function using the Taylor series expansion, and you can have several cross terms and so on. So these are the cross terms you will gonna see right now. So I'm gonna use the Taylor series expansion. I'm gonna write here that, okay, fine, what you can do is that you can have this a plus h and b plus k, and you can just subtract this, the same point at which you want to evaluate the function. Then it will come out to be like 2 of factorial, and you will have this h of square del 2f over del x square plus 2hk del 2f over del x del y, and then again there is a one more thing like k square del 2f over del y square. So you see this is the cross term that is involved here, because f is again made up of 2 points, and you already understand how we can evaluate. When we are trying to evaluate the function derivative with respect to x, then y is constant, and when we do the y, then x is constant. Okay, so here you have to take x and y both or by order wise. So when we are taking the derivative or partial derivative, we need to understand at which order we are preferring. Okay, so now I'm going to define something. Okay, let me just choose a different color over it, color for it. ओके, सो अब मैं क्या करूंगा, मैं इसमें काम करता हूं कि मैं कुछ चीज़ों को डिफाइन कर लेता हूं. लेट से इसको मैं क्या कहूंगा, इसको मैं कहता हूं r, उसके बाद d2f ओवर dx एंड dy को मैं कहूंगा s कहूंगा, और इसको मैं क्या कहूंगा, t कहूंगा. ठीक है ना. तो मेरे पास जो फंक्शन है वो क्या है, मेरे पास फंक्शन है a प्लस एच में और b प्लस के में, उसको मैं सब्ट्रैक्ट कर रहा हूँ a कोमा b से, और इसी वजह से मेरा जो फर्स्ट डेरिवेटिव था वो सब वैनिश हो चुका है, और मेरे पास जो आया वो क्या आया, 1/2 ऑफ फैक्टोरियल देन एच स्क्वायर आर स्क्वायर, बिकॉज दिस इज नॉट, सॉरी, दिस इज ओनली आर नॉट आर स्क्वायर, बिकॉज मैंने d2f ओवर dx स्क्वायर को r माना है. फिर मैं यहाँ कहूँगा 2hk एंड देन ये हो जाएगा मेरा s, isn't it, एंड देन k स्क्वायर एंड देन t. तो ये मेरा टोटल का टोटल बन जाएगा. अब मैं क्या कर सकता हूं, मैं इसे क्या कर सकता हूं, a स्क्वायर a प्लस बी होल स्क्वायर इंटू a माइनस a प्लस होल स्क्वायर में कन्वर्ट कर सकता हूं. सो अगर मैं उसे कन्वर्ट किया तो मेरे पास जो बचेगा वो क्या बचेगा. So what I can do, I can just first because these 2 factorial is again I don't care about it, because we need to determine that is this function will negative or the positive. So इसको हटा दो. अब मैं क्या करूंगा, मैं ये कर सकता हूं कि एक काम करते हैं ना, 1/r को अगर मैं डिवाइड कर दूं इन सब से, तो r/r में कर सकता हूं. ठीक है ना. तो मैं क्या करूंगा, यहाँ पे r/r लिया, एंड देन आई कैन सिंपली राइट 2hks प्लस k स्क्वायर ऑफ t, एंड देन व्हाट आई एम गोना डू हियर दैट 1/r h स्क्वायर r स्क्वायर प्लस 2hkrs प्लस rk स्क्वायर t. ओके, now you can easily see that you can have h square r square, then 2h hr is already there, and ks square. Okay, so if you can just take ks square h square r square plus 2hk rs, and plus I am going to take here ks whole square and ks whole square with a negative sign. Okay, and then plus rk square t, then I have here 1/r hr plus ks in whole squared, and here I can just simply take out what I can take out. I can just simply take out k squared, and here we will get s square, just negative common, and then we will get r t. Yeah, exactly. Yes. Now you understand from here that, okay, let me again do it like this, 1/r hr plus ks whole squared, just multiplying over here, like just multiplying this negative sign, I'm gonna take it inside. तो मैं क्या ले सकता हूँ यहाँ पे, आर टी माइनस एस स्क्वायर, ये मेरा हो गया। अब यहाँ पे देखोगे कि यहाँ पे कुछ भी हो जाए ये वाला, एज लॉन्ग एज मैं डिटरमाइन नहीं करता हूँ मेरा फंक्शन क्या रियल है, तो मैं ये कहता हूँ कि मेरा जो फंक्शन है वो रियल है। जब तक वो फंक्शन रियल होगा तभी मैं क्या कर सकता हूँ, उसकी मैक्सिमम और मिनिमा के बारे में हमें एक सेंस मिलता है कि ये मैक्सिमम मिनिमा कहाँ पे होगा। फॉर द कॉम्प्लेक्स फंक्शन इट डजंट मेक एनी काइंड ऑफ सेंस। तो मैं ये कहता हूं कि देखो भाई, फॉर एच एंड आर रियल होगा तो ये नेगेटिव होगा, तो ये हमेशा पॉजिटिव आएगा, तो मैं इसको हटाता हूं और मैं बोलूंगा कि इसका कोई काम नहीं है यहाँ पे टू डिटरमाइन द फंक्शनैलिटी ऑफ this subtraction. What I can write here that k square minus rt minus s square. Now देखो k आप कुछ भी हो सकता है as long as it is a again a real number, इसमें कोई प्रॉब्लम नहीं है। नाउ वी हैव सम कंडीशंस ऑन 1 बाई आर एंड आर टी माइनस एस स्क्वायर, ठीक है ना। तो कंडीशंस अब हम एक्सप्लोर करते हैं। तो कंडीशंस क्या होगा, देखो भाई कंडीशंस ये होगा कि मान लो पहले कि आर टी माइनस एस स्क्वायर इज ऑलरेडी पॉजिटिव, ये कंडीशन है, ठीक है ना। जब ये कंडीशन होगा तो अगर आर तुम्हारा जीरो होगा तो मैं क्या बोल सकता हूं, आर अगर मेरा जीरो होगा तो मेरा जो नेबरहुड है वो बड़ा हो जाएगा, देयरफॉर इट इज मिनिमा, ठीक है ना। तो r अगर मेरा जीरो हो गया, r इज ग्रेटर देन जीरो, देन इट इज मिनिमा। एंड व्हाट इज दिस r? r कैन बी इजीली फिगर आउट एट d2f ओवर dx स्क्वायर, आपने फिगर आउट कर दिया। इफ इट इज कमिंग आउट टू बी ग्रेटर देन जीरो, देन इट इज मिनिमा। ऑन द अदर हैंड, इफ योर r इज नेगेटिव, व्हाट डज इट मीन? इट मीन्स दैट ये जो आपने लिखा है a प्लस एच एंड b प्लस के एफ ऑफ a कॉमा b, अगर ये इसमें क्या होगा, ये वाला जो फंक्शन है काफी बड़ा हो जाएगा, इट मीन्स क्या होगा, ये नेगेटिव होगा, ठीक है ना। ये नेगेटिव होने का मतलब क्या बोलता है, ये जो फंक्शन है आपका जो नेबरहुड है वो मिनिमम हो जाएगा और जो पॉइंट है वो मैक्सिमम हो जाएगा, देयरफॉर दिस इज शोइंग विद द मैक्सिमा, ओके। On the other hand, what you can do here is that this is the condition that I have provided, rt minus s square, where r is greater than 0 and r is lesser than 0. Now I am going to jump on something very crucial, that okay, what if your rt minus s square is negative, okay. So now you can do several things, but you are limited when you are trying to determine. So let us say if rt minus s square is 0, so if it happens, okay, understood, if it happens, then it is becoming that you cannot just say something of this maxima or minima, you will have some kind of saddle point, okay. Now you don't care about it, what is the sign of r and so on, I don't care about it, just rt minus s square is negative and it is 0. How we can determine? And what is the meaning of saddle point? The saddle point is something like जब भी हम कुछ करते हैं, लेट अस से x माइनस वाई आपने लिखा और x प्लस वाई स्क्वायर लिखा यहाँ पर, तो ये क्या होता है बेसिकली, ये एक आपको वेक्टर पॉइंट लिखता है। ये बताता है कि आपका जो ये फ्लो होगा x और y का डिफरेंट वैल्यूज के लिए, वो कैसे फ्लो होता है, अंडरस्टूड। तो इस फ्लो को दिखाने के लिए हम क्या करते हैं, इसको इवेल्युएट करना शुरू करते हैं कि कोई भी चीज कहाँ से कैसे जा रहा है, इट्स लाइक ट्रेजेक्टरी समथिंग। तो मान लेते हैं कि हमारे पास कोई एक पॉइंट है, यहाँ पर एक पॉइंट हमें मिला, तो अगर मान लीजिए कि कोई भी एक फ्लो दिखाता है, यानी कोई भी पॉइंट अगर हमने यहाँ लिया, उसका वैल्यू फाइंड आउट करते हैं कि ये कैसे होगा, तो ये लेटर से ऐसे जा रहा है और यहाँ जाने के बाद वो फिर डाइवर्स कर जाता है, इस तरह से गायब होता है, मतलब कि यहाँ पे आता है और फिर यहाँ चले जाता है। तो यहाँ पे आप देख सकते हैं कि फ्रॉम दिस पॉइंट पर्सपेक्टिव क्या हो रहा है, फ्रॉम दिस पॉइंट पर्सपेक्टिव क्या हो रहा है, ये पॉइंट क्या है, ये पॉइंट फ्रॉम दिस पर्सपेक्टिव ये तो मैक्सिमम में है, एंड फ्रॉम हियर पर्सपेक्टिव ये क्या हो गया आपका, ये मिनिमम है। तो कहने का मतलब ये है कि this point is in certain sense that it is sometimes attract some trajectory, some vector points, and then after certain time all the vector points leaving from this point. So इसे हम क्या कहते हैं, इसे हम डायनेमिकल स्टेबिलिटी के टर्म्स में कहेंगे attractor and then as well as repeller. एक टाइम ऐसा लगता है ये पॉइंट के लिए कुछ पॉइंट से ये क्या होता है, मैक्सिमम है, लेकिन हम जैसे ही नेबरहुड में देखते हैं तो ये पॉइंट पता चलता है कि यहां से तो मिनिमा है। तो ये पॉइंट क्या करता है कि सर्टेन काइंड ऑफ वो दिखाता है कि एक जगह तुम्हें मिनिमा मिलेगा और उसी पॉइंट के नेबरहुड में क्या मिलेगा, तुम्हें मैक्सिमम मिलेगा। तो जब इस टाइप की चीजें हमें अगर देखने को मिलती है, जहां पे चीजें मतलब कि दोनों तरफ से ही बिहेव करता है, तो इसे हम कहते हैं एक तरफ से वो अट्रैक्टर लगता है, दूसरी तरफ से वो रिपेलर टाइप का लगता है, देन दिस काइंड ऑफ स्ट्रक्चर इज कॉल्ड द सैडल पॉइंट, इन विच वी कैन नॉट अंडरस्टैंड about we cannot tell that it is a maxima or the minima. So that is it, understood. So this is a very crucial thing. On the other hand, if you get that rt minus s square is equal to 0, then we cannot comment anything about this point, okay. So we don't know what will happen to this point, and therefore we need to again reassure things, or we need to understand things from a different perspective, okay. So now if what if rt minus s square is 0, then what will happen? You can understand from here that if rt minus s square is 0, then this whole quantity will vanish, will go away, and then you will left with this hr plus ks whole square, isn't it? hr plus ks whole square. So hr plus ks whole square, this will also become what is 0. So when this happens, we don't know anything about it. Okay, so I can simply say that this will happen, this will like hr is equal to ks, and then I can take the ratios between h over k and then minus s over r. And the thing is that we have some kind of ratio. You can also check it that if this function is can show any kind of maxima or minima, just you find out the ratio, and if these ratios are coming out to be equal with some negative sign, or it holds true, then you can say that I cannot comment anything about it. Then you have to use different kind of technique in order to understand the maxima and minima of this thing. So this is the whole concept of extremum to find out the extremum value. So now I'm going to re-summarize it, that how I'm going to give you the working, that how you can find out something. So you already know the definitions, that what is your r, s and t. So r over here is d2f over dx square, d2f over dx dy, d2f over dx dy square. Okay, so these are just your r, s and t. Now what you can do, you can just find out your a and b by solving this del f over del x and del y is will give you a, and this will give you the p. So these are, we can also call as the critical points of the function, understood? And then we can easily calculate this r and r s t at this point, r s and t at this point. So whenever you will get something, you just put the values of this one and this one. So if you came out to be that r minus st square, is it rt minus s square? Yeah, rt minus s square. So if you have rt minus s square is coming out to be positive, then it will depend that what's your r is lesser or r is greater. Okay, on the other hand, if your rt minus s square is negative, then the point is saddle. It means that it will behave like an attractor as well as repeller, or from some perspective it is looking at a minima, or from other perspective it looks like a maxima. Okay, and if you have got some kind of ratio, like ratio of this thing, then you can say that okay, I cannot tell anything about it. So I hope that this whole task is very clear, and it's crucial to understand the behaving of some kind of function, because as I told you that suppose somebody has given you that some function considered to be x square plus y square is equal to r square, then how you can understand that what could be the maxima or minima of this certain kind of function. Okay, so let us you can say that okay, let us say fxy is equal to x square plus y square. Then you can simply tell it okay, del f over del x is equal to 2x, and this is equal to x, therefore I told you that this x is equal to 0. On the other hand, del f over del y is equal to 0. Yeah, again y is equal to 0, correct? So if you want to find anything over here like d2f over dx square, then you can say 2 is greater than 0. And if del 2phi over del y square is again the 2, then again it is 0, no problem. So I told you that this is r and this is s, and I can easily find out d2f over dy, and I can easily find out del 2f over del x del y. So it will come out to be like what? So here it will give you 2y, and then again if you put the derivative with x, and it will give you 0. So you see over here that r minus st square. Okay, so r minus st square will be what? So r is 2, your already t is 0, it is 0, and therefore it is 2, so it is positive. Well, and what is r? Now since r is positive, then we can say that f 0 comma 0 will be the minimum of this curvature. That's it, guys. So using these kind of recipe, we can understand that what could be the minima, and here the minima just exists over here, and there is no any other maxima at other point because we don't have any other point. So from here everything will look like the minimum. So this is the recipe to understand, to find out the extremum of certain functions, and from there we can understand a lot of things about many things. So I am finishing this video by saying that please subscribe my video and join in this campaign. We are doing this job for various students who don't understand so many things, and the mathematical physics is a very crucial aspect to understand the physics in a better way. So if you don't understand this concept, then you are lacking something very important. So अगर तुम अपने फिजिक्स को स्ट्रॉन्ग करना चाहते हो तो ट्राई ये करो कि जितना हो सके अपनी मैथमेटिक्स को, कॉन्सेप्ट्स को बहुत ही ज़्यादा स्ट्रॉन्ग करो, बिकॉज यही आपको देता है एक पर्सपेक्टिव to become a good researcher in future and to have a great understanding when you are going to simply enjoy physics. Physics is not about just telling a story and philosophical things. It's more using your mathematics. You can have a lot of idea and testing these ideas, and when you are think anything from the mathematical perspective, then you will think, oh my god, it is very enjoyment. And sometimes you will fall in love with mathematics. Okay, so evaluating theorems and all these things. It's kind of a mechanism. So you don't understand so many things, and else just giving some kind of assumptions, laid out some assumptions, और उसके बाद कुछ चीज़ों को तुम assume कर सकते हो. assume करने के बाद कोई भी चीज़ें कैसे वर्क करेगा नहीं करेगा उसके बारे में हम हर चीज़ जान सकते हैं. Just using the mathematics, you see the power of mathematics. That's why I'm stressing each and every student. You must have to learn the mathematics, the basic of mathematics, and this is very fantastic. So I'm closing this video right now. This is Saddam Cap signing out.